Good morning to everyone. This is Dr. Polaiah, working as a professor in the Department of IT, Institute of Aeronautical Engineering, Hyderabad. So today I'm very glad to inform you that we are going to discuss the topic definition and technology on pseudo color image processing, which help us to understand how we can define a color image processing by the concept of pseudo color image processing. And now which we are going to define each and every that term about color image processing in terms of the concept which we already discussed, but short way and the definition way how we had to remember is pseudo color image processing. Actually, this approach is for assigning color to monochrome images based on properties of grid level content. Monochrome images is the term. Monochrome is usually taken to mean the same as black and white, or more likely grayscale, but may also be used to refer to other combination containing only tones of a single color, such as green, I'll repeat, green and white or green and red. So such colors which we are going to be keeping to the approach, three approaches. One is intensity slicing and coloring coding. Second one is gray level to color transformation, and third approach is filtering approach. Okay. So once we understand this simple concept, let we can go in detail about this pseudo color image processing, how we are going to be understand in terms of categorization. So there are two main categories of color image processing. Number one, pseudo color image processing. Number two, full color image processing, where we are concentrating about true color versus false color in the aspect of pseudo color image processing. If you want to define true color images are images with a natural color rendition. A red apple appears as a red, a blue ocean appears blue, etc. It is the difficult to achieve absolute true color in a color image processing. But your being approximately closer to human perception is acceptable. Whereas we are going to be define about false color images on this aspect of two categorization of color image processing. So we are using another hand that sacrifice natural color rendition in order to facilitate the detection of some objects. They are mainly used for satellite and space images. Satellite and space. So this is the major difference between two categories of color image processing in aspect of true color versus false color. We are going to see in detail about based on true color and false color image processing. We are going to be defined right now pseudo color image processing. So pseudo color images are originally grayscale, which are assigned colors based on the intensity values. Typical usage of these images is for thermography, where the only variable or the only available is infrared radiation instead of lights. The another example is elevation map. So let we going to see this typical usage of these images, especially in terms of thermography, where how the infrared radiation is instead of lights, we can be appear in aspect of pseudo color images. You can see this NASA picture, how this pseudo color image processing concept has been used and processed in aspect of the finding in an evaluation map. This is evaluation. So see how we are evaluating is by the help of scaling. So we have the thermography here, the radiation, the thermal radiation, which we are considered in terms of centigrade or in terms of Fahrenheit. So where we understand about centigrade, so it is varies in between 20 to 35. It is varying in between 20 to 35. So each radiation, you may observe that the color may be different. The color may be different. Okay. So these colors are changes in aspect of compare with same in foreign degrees. It may be appear the same, but the radiation is different. Okay. So here the maximum of centigrade we may equating to the Fahrenheit also it may be changes. That observation, that evaluation map will help us to understand how the image, which is pseudo color image, which is pseudo color image, is used for thermography image processing. Thermography image processing. Okay. So next, if we want to extend that pseudo color image processing definition, we can extend in terms of pseudo color image processing, which is we consider in simple case. In a simple case of pseudo color image processing, we call it as intensity slicing. So what do you mean intensity slicing is, this is a simple case of pseudo color image processing. It is also called density slicing or color coding. Okay. So if you want to define now, we want to remember right now about what does it mean. The density slicing is nothing but intensity slicing. Or we also remember that it is nothing but color coding. So how we may define such a simple case of pseudo color image processing in terms of density slicing or color coding in aspect of assume, that is imagine or assume a grayscale image as a 3D function with the intensity being the third dimension. So placing a plane parallel to the horizontal plane for pixel position coordinates would slice the images into two parts. After that, we can assign different colors to different levels, which are we are understanding. So we can remember this. The definition of intensity slicing is here color coding. That too, we are understanding that information in aspect of pixel position coordinates would slice the image into two parts. After that, we can assign the different colors to the different levels. That is the meaning of slicing, intensity slicing. So if you want to see that pseudo color image processing in aspect of transformation, what is that called as a color transformation? We call as a color transformation. We say color transformation. This color transformation we want to understand from your grayscale image or from your 2D image or from your objective function. From your objective function. From your object. What we can understand here is f of x comma y, where red transformation is f for x comma y. That means your f of x comma y is transformed right now only for red color image processing. Whereas if you go to green color transformation, that we notation we define f suffix g of x comma y. So where your object function of an image of an image is right now transformed to the blue color is fb. That is, we simply say f suffix b of x comma y. So this is what we want to understand as a pseudo color image processing simple functional block diagram in aspect of color transformation definition. So where we can also concentrate the simple pseudo color image processing in aspect of full color image processing, as we consider to define in terms of different approaches. So what do you mean that different approaches? What does it? How can you define it? We define full color image processing approaches fall into two major categories. Number one, I repeat, number one is approaches that process component image individually and then form a composite processed color image from the individual processed components. And whereas second one approaches that work with color pixels directly in full color images. Color images really are vectors. For example, RGB system, that is RGB color image system, each color pixel can be exceed as your defined range. So that defined range is here C of x comma y is equal to CR. R means red, G means green, B means blue, CR, C means color. CR of x comma y is converted into pure complete image like that. So for an image of the each size, that is m by n size, is here mn such vectors of C of x comma y, where x will be defined 0 comma 1, and that is one aspect. Whereas 2 is m minus 1. This m minus 1 is nothing but where is in aspect of axis y 0 1 to n minus 1. X will be 0 comma 1 comma 2, but whereas y value will vary up to n minus 1. So this is what we can understand about the full color image processing in aspect of two categories. The second categories of axis range is limited towards to define in the matrixation formation. So next we extend that pseudo color image processing in terms of color image, which is right now defined in terms of smoothing and sharpening. That color image smoothing is a part of pre-processing techniques intended for removing possible image perturbations without losing image information. Analogously, sharpening is a pre-processing technique that plays an important role for feature extraction in image processing. A method should sharpen digital color images that taken viewing conditions and human vision models into consideration is discussed. So the method combines the Laplacian of Gaussian, that is, we simply define in notation as a terminology LOG operator, with a spatial filter that approximate the contrast sensitivity functions of human visual system. It is extended in aspect of or in terms of two important pre-processing techniques within the computer vision field. So what are those? How can you define? Number one is smoothing. Smoothing is to define where depends on consists on the removal of possible image perturbations resulted from the image acquisition. So sharpening is in sharpening is in charge of the improvement of the image visual appearance and the enhancement of detail and borders of the image. Is there exists a lot of smoothing and sharpening methods that are able to improve the visual quality images. So how those visual quality images, I wanted to show some examples while you're defining about a color image processing in terms of smoothing and sharpening. We can define this is your original image. From the original image you transform to in terms of smoothing, you can compare both. In terms of sharpening, you can compare both. So that is what we want to understand from this image smoothing and sharpening. So these applications are developed by the usage of MATLAB toolbox. What is your MATLAB toolbox here? Digital image processing. Toolbox. Where in MATLAB. I hope you understood this part. So whereas we can go ahead for the define of data compression, a central role in the storage and the transmission of color images, or simply we keep in the data compression. What is the data here? The data is here the red, green, and blue components of the pixels information keeping in RGB image. That means the color transfer, the color information is conveyed. Compression means what? Compression means is the process of reducing or elimination of redundant information or relevant data. What does it mean redundant? Is repeated information. So we got right now the definition and clarity about data and compression. So coming to the color image compression, we extendedly keep in terms of understanding as the objective way to minimize the number of bits required to represent an image is called color image compression. Or else, image data compression methods fall into two common categories. Number one, information information preserving compression. That is especially for image achieving, that is storage of legal or or medical records. So next, second one is lossy image compression. So provide higher levels of data reduction that resultant in less than perfect uh, reduction of the original image. So how it may be effectively can observe one between to the other. So with this, I want to close today our discussion about this ELRB on definitions and terminology towards to understand pseudo color image processing. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.